There we go. So I hope folks are here and you can see things. Yesterday I didn't set up screen sharing properly. Uh, Anybody there? I understand there are about 22, which was good for an 8:30 class. It's actually better than what I was getting yesterday at 1 o'clock. I have a microphone on? Yes. Someone want to type, say hello? Make sure that you actually are there and I've got this working right. Ah, good. Kristen, thank you very much. Hello. Thank you. I never can tell because I can't see you. Anyway, if you're in Halifax, this morning is, well, it's burning off now. It's really, really changed in the last 15 minutes. Um, just came back from walking Dora and we really had a challenging bit of a walk because you could barely see across the street and we get a lot of traffic not far from us. So picking our walk to be safe. This is fog of probably Friday morning, looking up the northwest arm. And it was a lovely, quiet morning. Duck that was just coming into land there in the middle. But today I didn't take a picture because it's you can't see anything. But I did yesterday evening, and I think it's worth noting. This is roughly the same location. This is after the rain finished. It was around 6:30 in the evening, and we were down same sort of location for our walk. And there was a rainbow, and it was just delightful. And I don't know if you can see over here, but there's a, a heron that's right on the bow of this boat. It's got its wings spread. I wish I had a. I've got such an old phone for a camera. I should have something better quality to take better shots of this sort of thing. I could actually see that bird then. Anyway, let's get on with our show. We had just a heads up that yesterday all kinds of technical problems with uh, Top Hat and everything. We worked around it, no trouble. They've made some upgrades, and I think we got caught up in a little bit of some things not working exactly right. So I've got a number of updates. I'm still way behind in my work. I'm trying to get caught up. Um, that marking of your test one, I'm still getting some emails on that. That I'll send out an email to everybody when I finally got the marking done on it. And until then, any grade you see on Top Hat is an incomplete grade. It took me a while trying to figure out how do I do marking in Top Hat. It turns out um, with your test, it's only 4 questions I have to grade. It shouldn't take me that long, but it's taking me a while. Um, that the like question 17, I had to mark everybody's question 17 before I was allowed to look at question 18, or at least that's the way it seems. And uh, so you'll see your grade inch up as I go through each question. And if you don't see it moving, it may well be because I just haven't marked it yet, but I'm working at it. I'll get it done as quickly as I can. Assignment one marking, it actually started yesterday. Um, that uh, we had a variety of issues. I should have three, since we have three sections, have three students working for me to help me with the marking. But unfortunately, I've only got two. I haven't been able to locate a good third one. Um, and but even when I got them set up, Top Hat wouldn't let them actually grade your assignments. They couldn't get access. I had to go in and I've changed their status now to professor on Top Hat. So they've got the same rights as myself. And if they want to delete everything that's there, they could. They're good people, though. They won't do that to me. Um, and I know one of them at least, she's been very busy yesterday doing marking. And so it may well be for, I'm not sure which section she is marking. And I've got to go in and check to see how things went with that. But I'm pretty sure she spent the day yesterday marking the assignment. That just a warning, don't read too much into Top Hat's grade book. Uh, because as soon as you submit something, it starts showing up as a grade of 0. And until we put in a grade, particularly if it has to be manually graded, it'll stay as a 0. If it's a quiz, then it's until the quiz closes that it stays as a 0. So there are a variety of those things. I've had some students reporting problems with the assignment, not from this section, but from one of the others they did. And it may be that I set up something incorrectly uh, with the way I was trying to split the assignment workload into 3 sections. Um, and But if you're running into problems, please send me an email. I ended up accepting some assignments by email. We've also had students raising questions about quizzes. I'm trying to fix as many of those as I can. Um, but please let me know if it happens. And if I'm supposed to fix something and it's still saying the same, I'd say remind me every Monday, send me an email saying, when are you going to fix it? That It's just a lot to keep track of with all of you because there's unfortunately a lot of little tiny things that are happening to so many different students. And I'm just having trouble keeping on top of all of it. But we'll get it sorted. Don't worry. It'll run smoother as the term goes on, and we've discovered what we're doing, what I'm doing wrong. This week, I've posted a discussion. I see there's almost 30 students have participated already. I apologize. Last week, I forgot to post one. I'll try to post one every week that has to do with, in general, it may not fit exactly with the topic of the week, but I want to present situations that involve analyzing data or drawing conclusions from data. And uh, at the moment, I'm hitting on questions more that are getting you to be skeptical or challenge conclusions that people draw. And the one I picked this week, because I'm trying to pick ones that um, you can relate to, that are more personal, if at all possible. And a number of years back, I used to work with the Maritime Provinces Higher Education Commission, the body that oversees the universities in the Maritime Provinces of Canada. And they were doing research on students, and one of their lead researchers had noted they were studying the average time it takes a student to graduate. How many years does it take, or how many terms of study? And ideally, in a 4-year degree, you should be able to graduate in 4 years. But actually, less than half of students graduate in 4 years. That many of them take 5, some 6, 7 years longer. And this is of those that started full time. Uh, and what they noted was that students not taking a full course load were very unlikely to graduate on time. And so they were suggesting to government, and MPHEC reports to the provincial governments, that the government should be pushing universities to get all students to do a full course load. And I took issue with them. I said, no, that's wrong conclusion. Um, it's a more complex problem than that. But the Nova Scotia government did implement for a time, I don't know if it's still there, financial incentives to reward students that graduate in 4 years. They got a financial incentive from the government. I don't know, I can't remember if it was a tax break at graduation or if they paid off part of the student loan. But there was a reward for finishing in 4 years. In the US, this is a very common practice, and there are agencies in the US that are strongly promoting students, push your students to do a full course load, um, either um, make it hard for them not to take a full course load, or give them a financial reward, or if necessary, penalize them for doing 4 courses instead of 5 courses. Uh, I don't agree. And that's the topic. So here the data is suggesting it's a good thing to do if you want students to graduate in a timely fashion. And there are lots of rewards for graduating in 4 years instead of taking longer. But um, is it as simple as that? Nothing ever is. Anyway, so throw in your 2 cents worth. You may end up, you'll probably be repeating what other people have said, but still you can down what your thoughts are before you read what everybody else had to say. Test number 2 is on Friday. I'm working on it at the moment. And uh, because of the delays with test 1, because of me marking short answer questions, I decided to make test 2 only multiple choice. And some of the short answer questions that I've got for test 2, I'm rewriting to make them into multiple choice or ones that could be graded automatically and you'll get faster feedback. That the uh, uh, in going in developing questions, you may have noticed in chapter 4 there were only 7 questions at the end of the chapter. That was because it was so hard for me to find 7 questions to ask that were multiple choice or simple that I didn't have you actually actively using Excel to do. Well, I'll have you using Excel in your assignments. I don't like making you use it in a quiz. There's too much chance of something going wrong. So um, I'm still struggling making up. I've made up a number for um, your test, but I can't come up with 40 questions. And that's what I'd need to be able to have enough for your quiz or for your test 2 and to have a sample. So use quiz 3 and 4 as your samples, those to give you an idea of the types of questions I'll ask. And I'll try to restrict myself to ones that are within that sort of umbrella of ones of types of topics. I don't think there's really much outside of what you might have seen there. And the uh, I, I'll try not to have any surprises on test number 2 on Friday. Um, and next Monday is Thanksgiving. So the Monday class doesn't have a class, but you have a class on Tuesday. And we're into a rhythm of, um, for you starting a chapter on Thursday, finishing it on Tuesday, and on through, and the same with the other one. So I'm going to record a lecture for them and post it on Monday. If they want to see it, they can. They don't have to attend a lecture. Um, but we're going to keep on with the same rhythm that we've got right now, despite the holiday. So last class we did pivot tables and looking at how to use that as a very powerful tool to summarize averages. And we looked at patterns in averages across rows and columns. We were able to look at subgroups. We hid groups that were not important to us. Some groups that were small, we grouped together. Categories, like for an ordinal type variable where they should be in a sequence, we reordered them. That uh, we did a lot of different sorts of things. All of these little bits that we did were to reformat that table to make it more readable, make it easier for us to see the patterns, see the big patterns, and uh, look for the big things. That those are the ones that'll drive decisions. Little changes generally don't change our business practice. If I offer you a $1 discount to change your cell phone provider, you won't do it. But if you were offered a reduction of $15 a month or $20 a month to change providers, you would seriously consider it. Big changes are generally needed for us to take some type of action. But the other warning I have on those things is that the numbers we've got are only estimates. They're not perfect. There's a margin of error to them. The true value might be a somewhat higher or somewhat lower. And so if there's small differences, it may be just due to the margin of error. So be cautious about that. And that margin of error gets bigger with small samples. And when we're organizing stuff into this table and taking those 800 values and splitting them into 4 rows, 5 columns, those are 20 boxes. So each of the boxes on average might only have 40 values in it. And some might have only 2 values, and some might have 80 or 90 values. As you subdivide your data, you may get some very, very small groups and some very unreliable estimates. So you have to be cautious in interpreting this unless you've got a huge, huge data set. And we aren't going to have that in this course. And in many instances, even having 10,000 observations isn't big enough to be able to drill down too deeply. Oh dear. Is it stopping me again? Yeah, my slides are stuck again, I think. All right. Let me try this one more time. No, it's not working. Hold on. Let me move that out of the way and whoops. Yeah, it's not what I want to do. I just want to go down here, see if I click on this. Next slide. Nope. See, it's blocking me. That happened yesterday too. We only got to about 8 slides. So we're going to do what we did yesterday. I'm going to get rid of, I don't need that anyway. I'm going to get my slides this way. We're going back to my original PowerPoint then. So hopefully you can see this. Can you see this slide now in PowerPoint? Can someone just say yes or no? You can see a slide? Yes. Okay, good. Um, so what we're going to look at today is still using pivot tables, and we're going to look primarily at categorical variables. So we looked at averages last time. I'm going to be looking at percentages primarily today. We'll be looking at pivot charts as a way to display that. And but I am going to look at numeric variables because when we looked before at averages as one way of summarizing numeric data, we also looked at histograms and frequency distributions as a way of summarizing numeric data. And we can do that in Excel as well. And so we're going to go over to Excel and do that now, I think. Let me just make sure I'm into the right slide then. Okay, I got a few comments first. So, whoop, Dora's out there. Um, so I'm looking at, we're going to look a lot at frequency distributions, and then in a bigger sort of table called the contingency table, which is in a sense another type of frequency distribution. We're going to be looking at counts. And that was what was used within a histogram, was a counting sort of thing. So normally we do this type of stuff with categorical variables. Those are ones like gender or what program you're studying, uh, how concerned you are about finding a job, or about paying your fees. Those are categorical variables. Or numerical ones. And we'll still look at salaries once again today. Um, that, but with numeric ones, we actually created categories by grouping the numbers into categories of different ranges of values. So let's do some of this stuff within pivot tables and charts and using this count function. So I have posted the spreadsheet I'm using today. I think it's at the same level as I've got right now for where I'm going to start. And okay, let me go and look at it. So this is the one we had previously, and we've got things recoded as arts and home as Nova Scotia. There was a group of variables that we didn't work with, and I'll work with just one of them today, and that was level of concern about finding a job after you graduate, finding a job in your major, finding a job that has a salary that pays enough to live on, and it's a job that's where you want to live, that you don't have to go to Fort McMurray. That what I've done is I created a new lookup table called concern, and it took those numbers 1 to 6, added words to them, and then I recoded them all And I'm not trusting my job of recoding. I was getting strange results the other day, but those do look to be correct. Okay, so I'd like to go and look at this one here, any job, but I need to put that in a pivot table, and I don't have one right now. That since I've recoded my data, I should insert a new table. If you change your data after you've created a pivot table, you can refresh it. I tend to just go and create a new one. I don't trust myself. Okay, so I've got a new one, and I'll rename it my pivot table so I don't forget what it is. And what I'm going to look at now is this one, any job. How concerned are you about finding any job? And I'll drag that to the rows. Let me make this larger so you can see it better. There we go. And now I need something to summarize. I want a frequency count. And generally when doing a frequency count, what should we count? I'd recommend ID because every student in the survey had an ID. So drag that down to values. Not everybody answered every question. And I don't want sum. These numbers are the wrong values. So as we had before, we should go to value field settings, go over here to summarize the values by count, and click OK. So here's my 811 students, and here are all their responses. To interpret the table as a frequency table, this is what a frequency table is. It's the different categories and how many fit into each category. But this, I've got stuff in it I don't want, so I'm going to get them out of the way. So my first job is to make it, clean it, make it so it's easier to read. This is sort of like data preparation. The next problem I've got is I go neutral, not concerned, somewhat unconcerned, very concerned. This variable is ordinal. We're going from maybe a low level of concern to a very high level of concern, and so our categories should be in sequence. And we learned last week that we can move these things. So I'm going to go and just move them around, grab something. Whoops, doesn't want to let me move. Okay, hold on a second. Let's try this again. Let me try moving it. There we go. Move this one up to the beginning. Okay. And not concerned at all, I'm going to move it to the beginning. Move it to the beginning. Notice everything worked. Now, a second ago, actually, when I did this, it didn't work. Let me show you why. Notice I've got the category and the frequency count. If I've got both, sometimes it doesn't work. Go to move, it's all ghosted out. I can't move anything. That normally it's just the label that I'm moving. It'll move the numbers with me. But if you grab more than the label, it may not move. Just a heads up. I say why? I don't know. But Excel does things the way Excel wants to do things, it seems. So here's my level of concern, the frequency count of that. And as I had last time, I could make a chart to go and summarize this, and it'll put it into a column chart. And I strongly recommend you use the simplest chart that's suggested. Do not use 3D charts, and most of the time, don't use stack charts, but I'll leave that to the end of the course. For now, we're just going to do this. I'm going to make this smaller so I can see my table. A little smaller. Let me get this out of the way just for now. I'll bring it back later so I can see this. Okay. So there. So we're seeing there's a group that don't seem to be very concerned, and then we've got a bit of a trough, and then we've got another big group that are very concerned. Looking at these numbers, these frequency counts, they 101, that sounds like a big number. 221, that's an even bigger number. Looking at these numbers is difficult because I have to look at them in the context of being out of 794, around 800. We shouldn't have to do arithmetic, do math in our head. These should be more obvious to us. So generally, if we're looking at frequency data, I'd strongly recommend that you change the format so it's percentages. I can maybe able to do that here. If I right-clicked, I could get to value field settings. Ooh, here, look at that. And I could go to show values as, and I'm looking at a column of numbers. So I'll look at percentage of column. And if I'm making this tidy, this is a percentage. I only want it, I don't want decimals. Decimals are just too much information. Click OK. So this changes my thing to add up to 100%. And so it's 28 compared to 13 to 15, 24. They're all on the same scale. And it changes my chart, so it's percentage on the vertical scale. The look of this chart should stay exactly the same because I've not changed things. I've just divided through everything by 794. So that's sort of my initial thoughts on how to summarize things and make a nice frequency distribution. Let's see if that showed up. Yeah, that's what I did. Okay, that had the not sure, so I must have taken that out. Yeah, and see, I reformatted it. So I'm getting different numbers. Oh, those weren't sequenced. No, those were the table wasn't. But my graph was done afterwards. How did that happen? These numbers are different from what we've got for any job. I wonder why. This is strange. They may have messed up my data somehow, but we'll keep on going. It's the technique that's important. But these are important things to do. When you're making things readable, remove anything that's unnecessary, sequence if it's appropriate, and generally to show percentages. For most people, that makes things a lot more readable. But what I'd like to do now is look at numeric data. I've got to look into why my numbers are different. So let's go back here, and I need to get my field list back again. There we are. So what I'd like to do is take this away and look at salary. I'm going to put salary into the rows. It's still got percentages here. Ooh. All these zeros. We could go to format field settings and see if you wanted to, we could go and get rid of the percentages and just show the frequencies. Oh, okay. 5, 1, 1, 3. See, 5 people reported that they would earn nothing when they graduate. One person thought he had only earned $500 a year. 800. I don't know. I can't imagine these numbers. They're just so small. But if we look down this table, you would find nice round numbers like 20,000, 25,000, 30,000, 35, 40. See all the nice round numbers. We see lots of people, and that's because it's our nature to round things to nice numbers. And that's what you see here, is all those ones that were quite frequent. You're seeing as big spikes. And so I've got a whole range of these different big spikes. These are blanks at the end, I think, because my table here, see, I got 59 blanks. That's where the blanks are at the very end. Okay, and so they've lumped them all here. When we created a frequency distribution before for data, we grouped things, and when you did it as a histogram, you grouped values together. So can I group values together? we did grouping before. Remember, we grouped science and engineering together. And so we went and selected something and we hit group. This time I get a table. Let me just cancel that. Remember before we'd take, like, could I go and grab this group and group them as those that are under 5,000 and create categories that way? It doesn't work the same way with numeric data. With numeric data, oh, it did. Sorry, I didn't think it would do that. But I can use grouping by just picking one and do an automatic type of groups and not have to create labels for them. So I can do this using a tool up here called group selection, or the same way I did it before. So I'm going to hit group, gives me a table, starts at 0, ends at 650,000, and it goes by increments of 100,000. So using this quick tool, I've got to have the same group size, but I can say where it starts and where it ends. I'm going to start at 20,000. I don't believe the numbers that are smaller, and I'll end at 120. At 120,000, yeah. And so I'll go in increments of 10,000. That's how we built a histogram week, 2 weeks ago. And then click OK. And there's my histogram. Okay. And if I want to, I'm going to go back here, show values as percentage of column total. And I'm still going to get rid of my decimals. And now I've got a relative frequency histogram. It's the same as what I had previously. Okay. That here are my blanks and ones that are under 20,000. I thought I told it to have at least 20,000. It still keeps all the groups I give it. And I didn't want more than 120,000, but it still kept that. So it creates, if I limit the beginning and end, it creates extra groups to represent the ones I excluded at the beginning, the ones I excluded at the end. And if I really don't want to show them, I can hide them. I'm going to take those away. I'm going to take those away. Click OK. It'll adjust my relative frequencies to reflect that. So it's still 100%, having excluded values. So I've filtered them. I've grouped them. I've got a chart. If I wanted to, I could go and I didn't make you do this in the assignment. It's really not important, but know how to do it for a stats class, because most people that teach statistics are very traditional and they think a histogram should have no gaps. So I'll get rid of this. And there I've got a very traditional histogram showing goes up, goes down, long right-hand tail. It's somewhat skewed to the right. And that's common with financial types of data. So there I've got a histogram. Was this process easier than using a histogram function? You can be the judge. I like it. I feel like I've got control as I go along, and I can change things. I can format things maybe in a different way. I can do the filtering that I couldn't do with histogram, and I can do other things that I couldn't do with histogram. Suppose, and this we tried, well, I showed you what it looked like, but we didn't actively do it. It's hard to do with histogram. I could take program. Now, notice it's changed because of the type of data I'm working with. It now has columns as being legend series instead of columns. Okay. It's this very busy looking picture. And you can see in my table here, it's got arts, business, engineering, other, science, not applicable. I could group science and engineering if I want, but I'm going to go and just take out the ones I don't want here. I've mentioned before you can do that up here with the column labels and click them there. Or if I'm looking at my picture, I could pick here and I could take out engineering, other, not applicable. There we go. And just spread it out so you can see a little more clearly. And these are percentages that I've got. So this is the histogram, the blue one, for arts. The orange one is for business. And so it's shifted a little bit to the right, suggesting that by and large, not just on average, but by and large, business students expect to earn more. That fewer of them expect to earn low salaries and more of them expect to earn high salaries. And if I look at science students, it's shifted even more to the right. So even fewer science students expect to earn low incomes, and many more science students expect to earn very high incomes, very high incomes. Um, and these are relative frequencies. These are percentages. So slide this guy across here. There we go. So you can see they add all up to 100% because before I'd said I wanted things to be percentage of the column totals. And this is the arts column, the business column, the science column. And for each one, I can get this information here. And I can then compare them one to the other because they all add up to 100%. Again, I'm saying I should always be looking at percentages when looking at frequencies. And just to show you, remind you why, again, may be obvious, but just want to clear this up. If I gave it as just frequencies, I've got a small number of science students, you can see that, and many, many more arts and business students. And so in my chart, the arts and business students are similar in size, almost. So here was the arts pattern and the business pattern, and these look almost exactly the same as they did in the previous chart. But look at the science ones. Yes, very few expected to earn a lot of money, but look out here, we got very few of them out here too. Not what we had before, that the gray is generally very, very, very low. And that's because I've only got 102 science students, whereas I have 271 business students and 252 art students. So to compare the scale of the bars, I need to uh, have a common standard. And that, in this instance, is percentages. And generally, when we're going to be working with things, we're going to want percentages, not frequencies. Frequencies don't tell me what I need to know to be able to do comparisons. If you're really good with numbers and you're very comfortable, you could probably look at these patterns of numbers and see an 11 and a 13. Oh, they're about the same. But then note, oh, this group is much smaller than that one. And you can process it in your head and think, hey, that's a lot of science students. But that requires work that is unnecessary. You shouldn't have to go and do that extra thinking. And I'm of the mind that thinking is not, uh, it's good to think, but when you don't have to, that's a good thing too. Give your brain a rest. There are lots of other things you could then think about. Okay, so let's go back to PowerPoint and see if we're on track. So that was that spiky graph I had and percentages, and then I group stuff, and that, um, and I grouped it there, and I got my revised one like I had. I took out the extremes, and then I did it to do comparisons that generally give it a nice title. This is a generic one, salary expectations 2 years after graduation. That, or you can have one that tells a better story. You could have had a title that said science students expect to earn more after graduation. Okay, cat jumping over a board. Sam's getting too heavy, and to jump over things, he sometimes hits them. Okay. All right. And that was showing it with no calculation in the patterns. Okay. So let me go back and look at any job, and hopefully I'm going to get the right numbers. But and I want to look at different programs. So let me go back to Excel here. So I'm going to take salary, throw it out. Okay, I'm going to leave program there, and I'm going to take any job and throw it in. So first off, let me move my chart aside so I can look at the table. Yeah, these look to be backwards or something. So in this one here, I'm looking at arts, business, science students across here and their level of concern. Are they not concerned at all, somewhat concerned, unconcerned, neutral, somewhat concerned, very concerned? And when looking at the pattern that I've got here, I've got modest number that are very concerned. Yeah, I think I may have recoded them backwards. But if I'm comparing arts to business to science, it becomes awkward looking across here because they're frequencies. This table, whereas we've been talking of frequency tables before, this table is given a special name in a stats course. I'll just type it out. I don't know how easy it is to understand my words online. I'll know when I check the recording. This is called a contingency table instead of a frequency table. And it's because it's frequencies, but it's of two variables that you're describing. And generally, contingency tables describe the relationship or pattern between two variables. And generally within this table, the one I had before, I guess you could have called a contingency table for the salary groups versus program. But most of the time we use contingency tables looking at two variables that are both categorical. And this one up here, just to remind you, is a nominal variable because they're just words, whereas these ones here are ordinal variables because they're in order. There's a sequence to them. Okay, and and sometimes with a contingency table, it's important in studying ordinal variables because the sequence matters. And so I'd like to see, is there any pattern here? Is level of concern, is it the same for arts, business, and science? It varies from student to student, but does the pattern the same for each of them? So, and like I said before, with comparing them is hard to do. So I'd like to compare arts to business to science. So I'm going to compare this column to this one to this one. When you're comparing columns, then we should be, whoops, I did something wrong here. Then I'm going to change to percentages. I'm going to show values as, and it says no calculation. I can have percentage of the grand total of 702. I could look at the column total or the row total, or there's some other ones you could get into, but I don't recommend it. It's very rare that we'll ever do grand total. Maybe I will show you one late in the course, but from a practice standpoint, we don't use it. The interesting ones when looking for patterns are columns or rows. If I'm comparing columns, then I should look at percentage of column total. And again, I'm going to get rid of my decimals. This is a busy table. It's a lot of things in it. So this shows me that the at the low levels, not concerned at all, they look somewhat similar, although arts don't seem to be concerned very much at all. Yeah, I think I've got it coded backwards. and that this should be very concerned and that should be not concerned at all. But look at science. It's very high, this number here. So it would appear there's a lot of science students that are very concerned. So I've got a pattern potentially across the three. And as I've been making these changes, they've been showing up in my chart. So let me just show you my chart here. And how has it made the chart? And it's the same style as we had previously. Let me just move this down here. So in the chart, it takes these rows and it gives them across the bottom. And then the cluster it's creating, these are a clustered column chart. It's created a cluster here of arts, business, science, a cluster here of arts, business, science, another cluster of three, another cluster, another cluster. And so I can look at what's the pattern in arts here. I can look at the pattern in business, and I can look at the pattern in science. And it seems to be that we've got in each of the three faculties a cluster that are very concerned, and then a cluster that don't seem to be very concerned. Probably coming from different settings, different situations. It could well be that these ones down here are local students that have a job currently with an employer, and they expect to carry on with that type of thing after they graduate. So they're not really that worried about getting some sort of employment because they've got some now. Whereas these may be international students or students from away that don't have the same connections. And so they're more concerned about it. So there may be some other explanation, another variable that explains things for us. But from this, we can then see what's the pattern we have within our variables. Let's go back and make sure I'm keeping on track here. So I did the show values as, I did it as a column total that, and I showed it as percentages. And yeah, I've got my numbers backwards. So anyway, I've got the reverse in my labels that I should have had. Now, what happens, I'm suggesting here, what happens if we pick percentage of row total? What does that do to us? So go here, value field settings, show values as, I got, what does that do to us? Okay, so it gives us a whole bunch of different numbers here. Let's look at the chart as a way of looking at the pattern. It looks to be pretty stable across arts, 40%, 40%, and stable across business. There's no variation in concern in business students, and somewhat more science students are very concerned. But this suggests level of concern is, but then look at the numbers. How can I have art students 40% being not concerned at all, almost 50% being somewhat unconcerned, 40% being neutral, now up to 130%. These aren't adding up. And it isn't, because look down at my table. I'm not adding these up and getting 43% at the bottom. This is, in a sense, an average of that column, and this is an average of that column. I got them, I had percentage of the row total. So this adds to 100%. So what does 42% here mean? 42% is not the percentage of art students. It's the percentage of students not concerned at all is 42%. Let me just make a note of that. 42% of those not concerned are in arts. Well, that's not a surprise. About 40% of the students in the survey are in arts. So that's not a big surprising number. But notice what I'm saying. This is, when we study probability later, would be called a conditional probability, because I'm only looking at those that are not concerned. Previously, when I was doing stuff, need to move you out of the way and find this again. When it was percentage column total, okay, different pattern. 20% were up in this top corner. This says 20% of arts students are not concerned. Okay? So that of is an important word here, because this is, in this instance, I'm looking at the art students and how many are not concerned. In the previous one, I was looking at those that were not concerned and asking how many were in arts. This may seem like a pretty obvious, but these numbers are very different. And if you incorrectly identified the interpretation the other way around, you're going to get very, very different conclusions. These are vastly different situations. Um, you have to be extremely careful about what you're choosing as being your percentage. So if you're concerned, so let's just pick one that's, instead of this, let me look at a different variable. Take gender, throw it down here. Okay. That, now I've got table adding up to 100%. I'm going to get rid of those without gender. Okay. All right. So what does this table tell me? This table is going arts, business, science. And so I got female, male. Those are my two row labels. And the columns are the programs. So this is showing me the what? This is saying 75% of, I'm looking at the column, because it's percentage of column total. 75% of arts students are female. Okay? Because that's the way I'm looking at my data. And so this column, blue column, and that one will add to 100%. This orange one and this orange one will add to 100. The gray one and the gray one will add to 100. As I'm looking at percentage of column total. In business, women make up 54%. In science, that 64% are female. What would happen if I could do, instead of percentage of row and column total, what if I'd had these things the other way around? Flip, flip, flip. Okay. Now I got different numbers. What is this? This one now would be saying that 49 is 49% of, I'm going to look at the column, female students are in arts. By flipping my variables around, it's now arts, business, science. Okay? And this blue, that blue, that blue will add up to 100%. This orange, that orange, that orange will add to 100%. So this is showing me a different situation than the previous one. That this one says that women prefer arts, second choice business, third choice science. Among men, their first choice is business, second choice arts, third choice science. A different pattern than the previous chart, where I was saying that um, among females, they make up 75% of arts, that they make up a little more than 50% of business, and they make up 64% of science. So science may be the third choice of females, but they still make up the majority of science students. You have to think carefully. It's really easy to get yourself confused. I'm not saying that it's just going to jump out at you, but things that may at the beginning seem simple are not necessarily as simple as you thought. So where are we here? So, oh, there, see? That's flipping things around and doing those groups back and forth. That be careful what you're doing. And as you flip things from rows and columns, you may have to change percentage of row to percentage of column or whichever way around. If you want to flip things on their axes, be careful about your percentages in each instance. And oh, here, we can make this uglier if we want. What did I pick in the PowerPoint? Oh, agree. What do I have that had agree in it? I'm not sure. That let me say I wanted to look at the gender split by home is not a great variable to use. Um, Too many categories. If I was looking at what year you were in, whoops. Oh, it got mad at me, gave me a warning because I typed a whole bunch of things down below, and that's why it was giving me an error message. What I did here is I'm now looking, and I'm just going to get rid of, oh, I can't get rid of this guy easily, except over here. Excuse me. When you're filtering things out or pulling things out, you can do it in the table in many instances, but you can also do it over here by clicking them there. And so I want to get rid of this NA group that's there. And so what's this telling me? Okay, that I've got uh, the in arts, 74% are female, 26% are male. Okay. And of that 74%, that 74% is split between first, second, third, and fourth year. And this 26% is split between first, second, third, and fourth year. Looks like I've got a large number of fourth year art students responding to this survey. But I can add additional variables, different things here. So here I've got two things I'm categorizing the rows by, one variable here. I could drag home if I wanted to and do crazy things. You know, yeah, it's going to overwrite some stuff. And there's a whole bunch more. You should see what it's doing to our crazy graph. It's males first, second, third, and fourth year, females, where they're from. And it's got a long list. It's just you can't show it all because of the size of the chart. So I can do crazy things and show many variables at the same time in these charts, but I'm going to end up with lots of holes in my chart. You'll see lots of zeros here because I don't have students from Saskatchewan or not many from Alberta. It's going to become a very awkward looking chart. So you can do it, but generally I don't recommend it. Looking at two things at the same time that I try to convince you that there may be some challenges in interpreting the relationship between gender and program, and depending upon which way you look at it when you're looking at two variables. If I add in what year of study they're in or where they're from as another variable and try to show three things at the same time, very often it becomes overwhelming and it becomes too hard to understand. The other risk we've got is we get really tiny sample sizes. And we know we shouldn't be analyzing stuff when we don't have the data to be able to analyze it effectively. So there's some of those dangers that you can get into that will make things really messy. Um, oh, okay. I was using a variable that I've not got in your data set that I've got today. I was using a larger one previously. So we can do all kinds of different things with our data, but it isn't necessarily a good idea to do it. Okay? And sometimes you can continue seeing patterns. Um, Sometimes it becomes incredibly challenging too. But the my main warning is anytime you're adding these extra things in, look at the frequencies and look how small many of these numbers are. They're too small for us really to get reliable estimates from, and we should not be studying such small samples. Um, that what is a small sample? What's a margin of error look like? When we did descriptive statistics, I showed you that you could get a standard error as a measure of how accurate an average is, that some of us call the margin of error twice the standard error. So if you take standard error and double it, um, don't be surprised if you're off by that margin of error either way. That with uh, percentages, when you're studying them, there are precise formulas we can use to calculate this, but I tend to keep some numbers just in my head. If I was dealing with a sample of only 100 numbers, my margin of error could be about 10 percentage points either way, 2 times 5% that I've got here in this table here. That they, if I was dealing with a lot of the big surveys that are done by the news media and polling agencies and the like, they try to survey 800 to 1,000. And their margin of error is typically about 3 percentage points either way, 2 times 1.6. If you want to get more precise than that, you have to have really, really, really big surveys. And again, I think I've mentioned before, and uh, when looking at polls that we see every day are about the US election. And you may be tired of hearing about Donald Trump and what has he done today. Uh, it's um, it's turned politics into a reality TV show, I think. But anyway, there was a lot of talk um, at the end of last week and over the weekend about a poll, I think by NBC, that showed that the gap between Biden and Trump had widened to 14 percentage points. And that was a huge jump because previous to that, um, polls were showing it was maybe 7, 8 percentage points between the two, maybe 10. Um, Jumping up to 14 was a huge jump. But given the size of some of the surveys that were being done and the nature of them, and each of the surveys are different in the way they do it. So they get different results just because they collect their data differently. Um, and uh, one could argue that it may be that NBC's poll was just higher because of if they'd done the poll again, they probably wouldn't have gotten a 14% gap. They might have gotten an 11% gap or a 10% gap. That if you go 3 percentage points either way, that's a range of 6 points. So that's like going from 8 points to 14. That may be possible. It's hard to measure things super precisely with percentages unless you've got an incredibly large amount of data. And most of the time we don't. Uh, but these are numbers that you may just want to keep and think about. You will hear in the media, they should be reporting at least when they're reporting poll results, the accuracy of the poll. And that they might be saying that this poll is accurate to within 3.2 percentage points, 19 times out of 20. That's talking about margin of error. So be cautious about those things. Uh, a lot of people read too much into numbers, and that if my number can be off by 3, 4, 5, 6 percentage points, then telling me that the poll results were 14% or 14.2% or 13.7% means nothing. That's why I don't like decimals. is uh, that's precision, it really isn't there in the numbers. So just summarizing things, pivot tables are a really interesting tool for summarizing all kinds of data, both particularly frequency data, both numeric and categorical. Um, but they're also great for summarizing averages or totals or other types of measures. Percentages are often good when doing comparisons and getting a sense of scale, and scale is really important. I'll hammer away at scale. Too often people don't appreciate the importance of it in how it makes it easier or harder to interpret graphs and tables. Keep the tables simple, keep the charts simple. Sequence categories logically. So that may not be um, on an ordinal scale where we're going from very dissatisfied up to very satisfied. It may be that you've got different categories that uh, are in terms of product preference, of different brands people like. Put the most popular brand first, second most popular second, and down the list, so that you aren't distracted by the unpopular brands, or you're being attention is being drawn to the unpopular brands because they're all clumped together at the end. Those are nominal variables, but the sequence in which you put them can be very useful and very informative. That I like when summarizing the faculties at St. Mary's. Arts and business often rivaled each other in terms of size, so I always put them side by side and put science beside them because science was always sort of beside them. Yes. Um, that a lot of people find charts a lot, they process information faster when looking at a chart, at least in terms of general patterns. Tables are good if you have to drill into the tiny numbers. Comparing three variables is very confusing. Watch out for really small samples and watch out for the reliability of your estimates. Next class, I'll look at a different way of summarizing distributions instead of using histograms. What if I was comparing not three groups, but five groups or 50 groups? If I wanted to compare the distribution of incomes across all 50 states in the US, I'm not going to do it with a histogram. Even if I wanted to compare 10 provinces and 3 territories and what the pattern looks like, I'm not going to do it with histograms. There's just too much detail. So how can I make it simpler, but not have to just look at averages? I want to look at the whole pattern. And so we'll look at an old tool for that that is getting much back into favor among people in data mining, though it still isn't as popular with people in statistics. So in a stats course, you may not see this, but in a data mining one, you might. Anyway, that's it for today. See you again. Hope maybe you'll see me again on Thursday. Have a good day, and the fog looks like it's all gone. Take care.